Thanks everyone for coming out. We have a great session in store, going to be led by Westinghouse CTO Lou Martinez, and she'll be discussing how they're utilizing data and AI in the nuclear space. So without further ado, let's give Lou a warm welcome.
Hello. Thank you for hosting us. I'm not here alone. I have some of my colleagues there. Please just let them know. Westinghouse, they are the ones doing the magic on AI in nuclear. So I'm here to tell you, and probably you were not expecting that we were that advanced in nuclear utilizing AI. So I'm going to talk about how we are revolutionizing the nuclear industry with AI. And you are seeing some names there. I explain you what it is, HiVE and Bertha, and actually how we are utilizing some of the tools that Databricks has provided us in this industry. But first, I think it's interesting to understand a bit, and sorry for those that were on the previous session. It's not going to be as a fancy presentation, but I think it's important to understand a bit the context of the energy sector. And here it goes. As we were saying in some of the other previous sessions, as announced in the COP28 and the COP29, there are 31 countries around the world that they are aspire actually to triple the energy capacity by 2050. But getting nuclear capacity is not on-off, it takes time. The good thing is that when it's on, it lasts for many long time. How many of you, how old do you think the nuclear reactors they are in the United States? How old? 50? More or less, they are between 40 and 47 years old. But probably what you don't know is that all those reactors, they are getting life extensions. They're going to operate 40 more years, up till 80 years. And that's where data actually is so critical, because we don't only need to build new ones, we need to maintain the ones that actually are already operating all around the world. And to do that, we have a lot of data, and we can actually utilize it to operate better, and even to operate and obtain much more energy for the assets that they are already built. Is what we call power upgrades in our jargon. Some of the figures that you are seeing, they are coming mostly from the Energy International Agency that says actually what is the growth of nuclear in the mix. There have been two major phenomena in the last 2 years, or 3-4 years. One has been the invasion of Russia in Ukraine, where people has realized that actually on, off, and having the lights are not that simple, and that if you depend on other countries for your energy, there are a lot of things, great things from your population, your growth, the quality of life of people that you cannot achieve. So that has created, again, a lot of traction in nuclear, so we can complete other kind of energy sources like renewables, storage, because really we need all of the above. Why? Because now we have people like Databricks and all of us working in data that we want to scale up AI, and that needs a lot of energy. So the Energy International Agency estimate, yes, in the base load, I mean, I'm not even taking the best case scenario possible, that by 2030, we need almost to double. We will need only for the data centers 945 terabytes hour of capacity. That is a lot of gigas when you translate it, and that is a lot of reactors, and that is what you are seeing on these slides, the projections of Westinghouse. And we do everything. We have large reactors like the AP1000, 1.1 giga, SMRs, small modular reactors, 300 megawatts, micro reactors, 5 megas, and then all the work that we do with the current plants is giving this capacity. So we are expecting to have a lot of reactors to build. That is what you are seeing in this slide. Is part of the business of Westinghouse, is creating and provide carbon-free advanced technologies. You will see that we also have energy storage. It is the only non-nuclear technology that we do in Westinghouse and we develop. Why? Because it's thermal, and at the end of the day, a thermal system actually operates very similar. You have a nuclear island or a boiler depending on the technology. You have a balance of plant. And then since the Industrial Revolution, we have not invented anything better than then utilizing a turbine. So basically, nuclear does two things. It produces heat, and it produces, obviously, with the heat, electrons. So in any kind of energy that we need, even if it's not electricity, you can also utilize nuclear. But the core business, and where you're going to see a lot of the examples of AI that I'm going to use, is actually in this piece here, is operating the installed base, all those reactors around the world. And I will say that I think Westinghouse has probably like 50% of all the nuclear power without CO2 emissions that is produced has a part, a system, and an engineer that has worked on them. You just take out the ones probably from Russia, because even in China we work many years with our colleagues there and develop systems. So the Westinghouse digital transformation has started many years ago. Back in the days, for those who are very, very old, I'm not that old, but I have done my archaeology work. Westinghouse used to have one thing that it was called the Westinghouse Engineering Magazine. It started in 1928. So you see how old we are as a company. That means a lot of data, what is good for us and our business here. There is this magazine in the 50s where you see engineers in Westinghouse, in Pittsburgh, Pennsylvania, utilizing one of the first commercial IBM computers. So when people ask me when that the digital transformation started, I say, well, depend on what generation of digital you are talking about. And we have this incredible picture of engineers, nuclear engineers, working in this thing that if we saw you, some of you big your eyes, probably you don't even recognize it is a computer, it's a lot of bulbs and tubes and things like that. So you see, we have started since the beginning. But with data and with Databricks, it has been 5 years ago. We have a deep bench of data and nuclear experts. We have over 70 years of worth data that is coming from all those nuclear reactors that you have seen in the previous slide. We knew, you have to say, and somebody, I was on the CIO forum, say, well, your data is like your IP. I agree 100%. In nuclear, we are very cautious about the data. Why? First, because there is proprietary data, IP data. We have export control data that we cannot give to any other third countries because of the security of energy. So what is the consequence of that? Most of the people working in nuclear around the world, they work on primes. And when you are trying to introduce some of the tools as AI and Databricks, as you know well, slow down. So without a scalable, super secure cloud solution, the team that is here in the room were very, very struggling to see how we are going to do that. So 5 years ago, we started this adventure with Databricks to say how we can build our own infrastructure so we can be fully autonomous, our own destiny, and be sure that we convince our regulators or customers that actually is fully secure and that we can use it respecting the regulation. And that's how the adventure started, and we built this infrastructure that now we call HiVE, that allow us actually to own all those developments in-house. So to build a world-class and a nuclear-specific AI, and why nuclear-specific? As you can imagine, you cannot go to a public AI and start working, oh, what is my safety limit on this nuclear fuel? I mean, it's not going to happen. All the government will be back to us. It will be very complex. So that's why we need to build a nuclear specific. We cannot avoid hallucinations. We need to track all the value of what we are doing all the time. And why is nuclear specific? Because we own that infrastructure, even if it's based in other technologies. But we also have the data in-house with the experts that analyze that, and that is what it gives confidence actually on the results. The nuclear industry has always been very committed to safety, obviously, and reducing the risk as much as possible. So we built internally the capabilities. You are seeing here over 50 data, digital AI, software engineers in a nuclear company. We built the Data Citizen program that is to educate our colleagues in how to use all those things. And we have a very, very close collaboration with nuclear experts in-house, but also externally. We work obviously with the Atomic International Agency. We work with the different regulators, with the OCDE. We work in full transparency because we need a trustworthy AI, especially in nuclear, otherwise we cannot use it. And then Databricks has been our external partner, helping us with the different tools. And I think also this morning in some of the sessions, you see how siloed it usually, I'm sure in your businesses, you are seeing all that. And now we are starting to see how actually we can bring all that data in the same platform so we can scale it up and have a sole source of reason. So what we do, we created this HiVE that actually is the infrastructure, what we have for AI capabilities, and a dedicated team of nuclear engineers, highly secure compliance. So we have a specific committee that actually track everything. And my colleagues now are feeling really nice. Yes, it's very tough, that committee, but it's the secure that actually we are doing the right things and we are fully compliant. It's very important for our business. We built also a generative, on top of this system, we built an LLM system, we call it Bertha. Why Bertha? Because Bertha Loms was the first female mechanical engineer working in Westinghouse and working in the nuclear industry in the United States. And for us, it's like, ask Bertha. You are asking the legacy of all the know-how and the human ingenuity that has built nuclear into all those decades. So you see, when we talk about transformation, it's more a continuous, and Westinghouse has been always able to introduce each one of those technologies when they are ready into our own industry. If you follow social media, you will see every Thursday our communications team makes something super cool that is kind of coming back. So you will see something from the past that Westinghouse done, like the first nuclear civilian reactor in the United States, and they explain you all those kind of things. And there is this post that says, well, Westinghouse built this, and then at one point they say, and now we are building nuclear-specific AI. So it's how we bring a 20th century industry into the 21st century, and I don't think we cannot do it without nuclear. So what is how we reimagine nuclear? So this is one of the use cases and how we are transforming actually nuclear. We are a traditional business, obviously. Regulation is super expensive, so one of the use cases that actually we use the most and we are getting a lot of value is actually how to optimize the licensing process. There is always the decision of a nuclear engineer and a licensing expert, but just getting access to all the data from the US regulator, so they have this huge amount of data, database that is called ADAMS, very old-fashioned, kind of the 80s, 90s, very difficult to find information. What we are doing with our tools created with Databricks and thanks to HiVE is that the engineers now, they can ask literally what they are looking for, so they can find exactly what are the documents that they need to be compliant, instead of spending thousands of hours just navigating a database. This was very interesting because we started this, I think it was 3 years ago, and we were very scared because we were pumping all that data. It's public, everybody, you can Google it, Adams, you can have access because it's data in the public domain. It's just regulations on how you can or need to be compliant. So we call the NRC and we tell them, by the way, don't be surprised, we're not doing anything wrong. We are learning how to utilize AI. And the surprise was that they were very proactive, very interesting, and they have been helping us actually to build all these things. Another example, it is the talent shortage. You see the growth that we need. It is not the same to build one large reactors. One AP1000 represents roughly like 10,000 jobs. It can go up to 20,000 jobs during the construction phases. Well, if you need to build 10 of those in a almost a similar period of time, where you find all that people, where you find the people that work on the design, the licensing, the construction. So we are also starting to utilize AI as a tool, like this is your start like an intern when it's your proof of concept, and at one point it has to become and empower the way you are doing. So we know we cannot hire all that people simply because they don't exist in the market. So we know that we need to go through AI solutions so they can have access to all the knowledge that Westinghouse has, so they can do their work in a much more efficient way. And I will pause here. I will show you later some of the, I don't know what happened. I was not supposed to go to the end yet, but coming back. Okay, here we have the use cases. And I would like to showcase this is how we have done it. This is for the ones that are more technical. So together, Westinghouse and our partnership with Databricks, we created this multi-tier analytics environment complete with ML ops process that streamlines all the machine learning tools. The foundation also features very robust prototyping and experimenting things. That is also, we do a lot of also rapid prototyping. It fits very well the nuclear engineering mindset, so we can test, learn before actually we scale up. And we have dedicated workspaces for testing and deploying AI models. The new infrastructure has already saved hours on one of our business units that is called Digital and Optimization Services, because actually Westinghouse, we have this business unit where we develop software and digital products to our customers so they can operate better and be much more efficient on the maintenance, inspections, all those kind of things that needs to happen to run a plant. And because they already have some of our digital tools, there is this thing that is called configuration management system, and now we can enhance it actually with Bertha, with the LLM system, thanks to this infrastructure that we have been able to prove that is fully safe, and we can start having a hybrid compromise between primes and actually the crowd. To assist in the development of Bertha, Westinghouse has leveraged the Databricks Mosaic AI agent framework. It has been very, and I have seen the team were presenting me some of those proof of concepts, especially since the beginning of the year. I think it's accelerating, and actually they are becoming super efficient in the way once all that data, it is clear. The fact that we have the Data Citizen program, it means that the colleagues from, that they are not in our department, that they go through all the training, then they can have access to their tools. Obviously, all of this is transparent for them, but they can create their own proof of concepts, and they can talk with their own data. That has been really pretty impressive. At the end, it's kind of customize your generative AI to what you need. I really believe on that mode. I don't think everything can come top down. Especially with the new generation that we are seeing coming to the workforce, that they are incredibly autonomous on those things. And now we're starting to see that break between people that they were used to, I have a software, I just click and that's it, and people are like, I don't want that, I want the flexibility of this platform, and if you are telling me that I'm secure using it, then I have a lot of ideas. And there is one thing, I mean, that you're gonna be loved, but engineers usually don't like writing, is how it is. And people, they don't like to write their objectives and key results, is how it is. And we have one of these colleagues in Sweden that actually showcased how she built, this was utilizing another AI, but how he was using it to build an agent to draft the OKRs for her team and herself. And then what I understand is that a lot of people were like, I want that because I don't want to write my own OKRs. That is very difficult to prove an ROI. When I tell this to my CFO, I'd say, you are always asking me what is the result and the power and the value that is bringing back to the company, because all this is costing me money, Lou. And say, yeah, I know. How you identify that? I present him that use case with the OKRs and say, I want that because I don't like writing my OKRs neither. So you see, there are a lot of things with AI that can be incredible technical, like uploading fuel load sequence in a nuclear reactor, and then you have things that actually make simply your life easier. And those are the kind of things that we are experimenting. It is important to understand that in this platform we have the data and security. That is one of the pieces that you are seeing there. Data encrypted in motion, and the data integrity is super critical in our business. So we spend a lot of time. We have a full team of people working on the security actually, and bringing the latest technologies available just for the data security. We have also the centralized access control, that I think it has been also shared by other companies working with Databricks. Again, it's just to ensure the consistency on the security standards. The data lineage and auditing as well is how it helps to maintain, once more, the data usability in collaboration with the users and the end users of the platform. And then we have also the standards and compliance. So we have this committee that gave us the ethical use of AI. So there are a lot of things in nuclear that we cannot do. In the example I was using, for instance, on the how you optimize the uploading of fuel into a nuclear reactor, that takes a lot of hours and calculations by engineers. We develop a machine learning tool, what is very efficient. Well, the result of that machine learning tool, I cannot use it to train something else. It has to be always raw data that I know where it's coming from. And that is part of what the team also is doing to ensure that all that is well understood, and we have that good use of it. And then we have the global capabilities that is also related to an infrastructure that allows for control of data from multiple languages without various country export controls and regulations that they are different, and that is critical because we are a global company and we are based everywhere, so we are testing. And what I like is when sometimes at the very beginning last year the team say, hey, can you read this? I mean, we are doing translation in Spanish, in French, in different languages to be sure that actually we were fine-tuning correctly the tool. So that is also very critical, where we are thinking in scaling up AI in a global company. It looks like, oh yeah, it's easy because now we have all these agents on our phones and you can do it. It is not, especially when you are talking technical data, and it's a lot of hours that our data scientists spend until they get the right results so they can use it. I would like to showcase some of the use cases and how actually all this infrastructure that you have seen. So I presented a bit the strategy, why we are doing it, what is the view here, and then how we are using it in the daily life. So this is a bunch of them, and I will be very open to questions as well. So one of the things, obviously, is to extract, clean, and store machine data. So there are large industrial facilities. So obviously we have some facilities. We are not where we need to be there because we are still struggling. I'm honest. I mean, there are things that they work. Others we need to be a bit more patient. And it's difficult because we know that data exists, but actually they don't allow us to use it because we cannot prove that it's secure yet. We have, Westinghouse operates some of the largest nuclear fuel facilities. So there is one in the US, Colombia. We have another one in Västerås in Sweden. But there you start with the regulation of each country that is different, all those kind of things. But the team has been preparing already all that, and we know it's feasible. So usually our chief operating officer came to me, look, I have issues with the on-time delivery. Can we use AI? I always say this, of course we can. The barrier is not the technology. The barrier is the framework and the security of the data, and until legal, IT, ethical, doesn't give us the green light that we can use it, the team cannot help you. But the answer is absolutely, we are ready to do it. And we have other use cases. We are starting to work with less tactical facilities to prove that actually it's feasible as we grow on the knowledge and the cybersecurity of that data. It's just saying what I just said, but in a nicer way. There, and then another use case, I don't know if this is working, is computer vision. Yes, there. So you are seeing here, one of the things that is actually, sometimes it is a bit boring because we spend a lot of time in a nuclear plant just doing inspections. It doesn't mean that anything is wrong, but we need to be sure that it's right. So we do inspections about, are we going to find corrosion in the materials? Is there any weird material that by isotopy has grown? Sometimes the fuel, when it's working, you can have some debris and can create some issues in some of the tubes. So you need mostly, when we do inspections all the time, we are happy because the customer pay us for it, absolutely. So now we are seeing how we can use computer vision, because it's very risky. For those that has never been in a power plant, it's pretty impressive. You need to know to get dressed like an astronaut, get inside. You can be only an amount of time, and then you need to go out. So now, suddenly we have computer vision AI that actually can do that job for you, and you don't need to be inside the plant, and you only go to actually what you cannot do with a machine. So an AI application is designed to process video data in real time inside pressurized water reactors or boiled water reactors, mainly to detect some of those fuel assemblies debris. That is the example that we have done already some work on it. And we know from the business cases that it can reduce 25% of the inspection cost. So I'm sure you can say, but that is great, then let's do it all the time. Yeah, but you are changing the business model here. Because we were talking on the previous session about predictive maintenance is great. I've been trying to do predictive maintenance in nuclear for the last 15 years of my career. And only now I'm starting to see that maybe we're starting to see a solution to it. What is the problem? It's not the technology. You have seen on the pictures the technologies are ready. We have tested them, have incredible results. It's the business model. The president of that business unit, she come to me and say, look, I understand that, but when is the right moment for me to change business model? And what is the value proposition of this thing that you are creating? I see the value, I don't know how to sell it and how to meet my P&L with it. And this is something of the discussions that I'm having also here during the Databricks and Summit, to discuss with other peers how you make actually that transition and you build that value proposition. Is it equal important as the technology itself if you want to scale up some of those use cases? The licensing material, I already discussed about it. So we leverage Bertha, Gen AI, to generate licensing data and documentation. What is very neat is that it also, one thing that, again, engineers, they don't like writing, they like designing and doing their calculations and things like that. But the NRC asks you to write, and write a lot, and in a format. So now we are starting to see feedback. We are developing a microreactor. It's kind of a nuclear battery, only 5 megawatts. And obviously, the licensing process is very different from what we know from light water reactors and the large one. So sometimes they don't know how to present the information and those reports to the NRC. So thanks to all the data that we have compiled from what is in the public domain and the NRC versus what we have in our own documents, it gives them even the format. This is the template that you should use because it's going to be more successful. That is a huge game changer. If you have been following some of the executive orders from this administration, one of the executive orders is based actually on how we can streamline the licensing process, because it's what is slowing down a bit what we are doing and how we deploy these tools in nuclear. So those are some of the examples that I have. Thank you.